have Tyler here from CITL who's going to video the class. He's not going to video you guys, it's just me, for me to get some feedback. Okay? Before we start, attendance sheets as usual. Just sign and see your name. So, today's agenda, I'm just going to give you an introduction for this class. We're going to talk about, within the company, how to decide whether or not to invest in a project. And if we have multiple projects, which project to choose. There's five techniques to come up with that decision. We're going to go through all five and go through a small question for each. The final part is probably one of the most important parts, not in real life, but at least for this exam. The crossover rate. Darren said there hasn't been a year where he hasn't come up with a question on crossover rate. Okay? So I need your attention on the final part. Let's start. So, the big five. The big five are these. You have the NPV, the net present value. This is by far the most popular method and the most important. Okay? You have the IRR and the MIRR. And you also have, so these have a benefit, but they're not widely used because of their drawbacks. We're going to talk about them in a while. Usually people look at the NPV after they have two projects with a similar NPV. They look at the IRR because it gives them a different type of different kind of information. And finally, you have the payback and discounted payback. Very, very straightforward. Okay? So we'll teach you all of these today, guys. Good part is these two are easy. This one is slightly tricky, but I'll try to make it as simple as I can today. Okay? So, let's start with the NPV. What is an NPV? It's the net present value. Everything we've been teaching recently was the present value. Now we have an extra letter in the beginning, which is net. And what is net? So imagine we have a project that gives us these cash flows and costs us this much. The net present value equals the present value of all future cash flows, which is what we did previously, minus the cost. This guy. Okay? So this is present value, this is net present value. Any questions on this? Go straight to a question from the book. Project L costs $65,000. Cash inflows are $12,000 per year for 9 years, and your weighted average cost of capital, WACC, is 9%. Okay? We plot it here. And the question asks you for the project's net present value. You could do it the normal way, which is you discount each of these cash flows, but I'm gonna teach you how to do it on the financial calculator. Okay? This is really important, guys. I need to get your attention because one mistake and everything gets you won't get the answer either not for this or for the coming questions. So, 3 steps for the financial calculator. You have to clear the calculator. We'll add the cash flows, and then we'll calculate what we're trying to calculate. First of all, let's clear the calculator. You click cash flows. Second, clear work. Now you have a new sheet. Okay? Second part, we want to enter the cash flows. So you'll see cash flow 0. What's cash flow 0?
Is that the cost?
Exactly. So it's $65,000. What? You have to put a minus. So it's minus 65,000. And then click enter. Okay guys? When you click on the arrow going to the top, what will you get? F01. Right? Let's skip that for a while. Cash flow 1. What's cash flow 1?
12,000.
Let's enter $12,000. 12,000. Enter. And then you click up. So, what we could do, which isn't really efficient, is put cash flow 2 at 12,000, cash flow 3, 4, and so on. But that's not really efficient. So instead, we use the FO part of the function of the calculator. If you look at your calculator, you'll find something called FO1, right? And what FO1 shows you is the number of times cash flow 1 recurs. How many times has cash flow 1 recurred? Exactly. So for FO1, click 9, enter, and you're done. So right now, we should have entered our initial cash flow, 65,000, cash flow 1, 12,000, and we told the calculator to use cash flow 1 for 9 periods. Now we'll exit the system. To calculate the NPV, you click second, quit. Now you're outside of the system. Right now you have a calculator that has all of your cash flows, and you want to ask it to calculate the NPV. Okay? Click the NPV button. And what does it ask you for? It asks you for I, your interest rate. And what's your I?
9%.
Exactly. Put 9%, click enter. So now you've entered all of your inputs. If you click down, what will you get?
Net present value.
Yeah. So just click compute on the top left, and don't shout out the answer. I want you to put in your I clickers, please. So you have net present value, compute. If you get a number less than $1,000, it's A, this is B, this is C, and anything over $10,000 is D. Okay? Assuming some of you forgot the. No. Just wait another 20 seconds. So nearly all of you got the right answer. Okay, so the right answer is 6,942. Okay? You should have gotten this one. $6,942. Anyone who didn't get 6,000 and has a question, you can raise your hand. 6,942. Okay. We'll go to the next part. So we finished NPV, the most important valuation technique. Now we go for the IRR, the internal rate of return. So the IRR is the discount rate at which the project's NPV equals 0. Okay? You'll get the intuition behind it once you do it a couple of times. It just shows you what rate of return would you require that you would be indifferent whether or not to invest in this project. Okay? All you have to know now is the higher the better. The higher the IRR, the better. There are pros and cons to this. The main benefit of the internal rate of return is it shows you how much the margin of safety is of this project. Okay? Usually we look at the projects based on NPV. If we have two projects with a similar NPV, we look at the internal rate of return. The one with the higher IRR means it has a higher margin of safety. But it has drawbacks. Any non-normal project, we can't use the IRR method with. And what's a non-normal project? It's a project that has positive returns in 1 year and negative returns in another. We can't use the IRR. If you want to read more about it, he's probably going to ask you a conceptual question about it in the exam, page 395. Another drawback is it assumes it reinvests the cash flows at the same IRR, which is unreasonable. Okay, you'll get the intuition when you see a very high IRR. It's really hard to invest it at the same rate. You usually reinvest at your rate of return. If you want to know more about it, page 397 in the book. Okay? In order to resolve this issue, they came up with the MIRR, the modified internal rate of return, which is what we're going to do today. Okay? So, question 11-2. Same project, but now it asks you to calculate what's the internal rate of return of the project. So, we'll also use our financial calculator for this. Since we've already entered all of our cash flows, it's really straightforward. We just click, it has all of our inputs, we just click IRR, and it shows 0, and we click compute. What's the answer? What answer did you get? You just click on the IRR button, and you tell your calculator to compute it for you. 11.56%. Everyone should get the same answer. We're good? Second part, the modified internal rate of return. This is the only tricky part today. Okay, I just need your attention on this to give you the intuition behind it so it becomes easier. So the modified internal rate of return. It's an attempt to resolve the reinvestment issue of the IRR method. How do we work on this? On the book it'll tell you this is the definition of the internal rate of return. The discount rate at which the NPV equals 0. This is the definition of the modified internal rate of return. It's hard to explain it in simple terms, so I'll just give you the graph and see if you get it from that. So, we have the same issue. We have 9 cash flows, and if we calculate the IRR, it assumes that the $12,000 we get here, we have a return of 11%, which is unreasonable in real life. Usually, this 12,000 is reinvested at your rate of return. So for this company, for the old company, it's usually 9%. It takes the 12,000, invests it for 9 years at 9%, 8 years at 9%, 7, 6, and so on. Okay? We come up with a future value, and then we calculate the return on that basis between the cost and the future value of all of these cash flows. What does that look like? It's exact. I put it in a simple term, the same framework I showed you in the 3rd week of class. We put it in the calculator. We just input these numbers. The present value is the cost. The future value is the future value of our cash flows from year 1 to year 9. We plug these two in, n equals 9, and we calculate for the interest rate. Any questions on that? We're going to do an exercise of this right now. So, same exercise exactly. We have these cash flows. What's the project's modified internal rate of return? We want to calculate I here. How much is the N? It's 9 years. How much is the present value?
65,000.
65,000. What's the future value? That we don't know. Okay? And in order to calculate the future value, I'll come up with another framework in order to get the future value of all of these cash flows. I know this is like an annuity, a 9-year annuity. It's a $12,000 payment that I get for 9 years at an interest rate of 9%. Okay? So let's do this in 2 steps. What's the future value of these payments? Can somebody calculate that for me? I have $12,000 payments for 9 years. I assume that the present value is 0. I'm just looking at the payments, how much they're worth, at an interest rate of 9%. Anyone get the answer yet?
I got 156,252.
So we have a future value of 156,252. Everyone get the same answer? Anyone got a different answer? Yeah? So that's our future value. So the future value of all of these payments is 156,252. That's here. The present value is how much? $65,000. Don't forget the negative sign. Number of periods is 9 years. What's your modified internal rate of return? What's your MIR, guys?
24%?
How much?
24?
24. Did you put the did you put n is 9, present value is minus 65,000, future value? I think you forgot, you added the payments in, which you shouldn't. You shouldn't have the payments. Payments are 0 because the payments they counted for the future value. 10.23%. Everyone else should get 10.23%. Just as a rule of thumb, you know, if what you're doing is right or wrong, the modified internal rate of return is usually lower than the IRR. Whatever IRR you get, the MIRR should be lower. We're good, guys? Any questions on this? So, let's go for the payback. Very straightforward. So the idea is how long to get your money back. Okay? We have the same project. What is this project's payback period? So, you paid $65,000. How many years do you need until you get your money back? 12,000, 24,000, 36, 48, $60,000. So by year 5, we have $60,000. How much do we have left? 5,000. So So, in order to get my money back, I need 5 years. And what fraction of the 50th of the 60th do I need? It's whatever is remaining, $5,000, divided by whatever cash I'm going to get in that year. Okay? So the answer should be just under a half. How much is the answer?
5.42.
Exactly. So it's 5 years, 0.42. 5.42 years. Okay? This is the only tricky part, because it makes a difference if you get it in 5 years in 1 day or 5 years in 11 months. That's why we calculate it. Okay? Any questions on this? We're good? So, just one trick here. How the book calculates it is they just take 65,000 divided by 12,000 and you get the same number. So this works only when your cash flows are constant. Don't do that if they're not. Okay? I don't want you to fall into this trap. Second part, discounted payback. Your discounted payback is exactly the same thing. How long is your payback? But you calculate the discounted value of the cash. Why is that? Because you're paying $65,000 today, and you're getting the cash in the future. $12,000 next year isn't worth $12,000. It's worth a bit less. So what they're trying to do here is what he's saying is calculate the discounted cash flow for each cash flow. So I'll discount this for one period, which is 12,000, discounted for one period, to the power of 1. I'll discount this guy for 2 periods, and so on. And so on. Okay? When I do that for all the years, this is what I'll get. And I'll do the same technique as we did before. How many years until I get all of my money back? Good with this, guys? You realize here it's usually the discounted payback is more than the normal payback. So the first one was 5.4 years. This one is over 7 years until I get my money back. Go.
Should you go over time how you calculated the 5.4
Yeah.
years?
Yes. Let's go back to 5 point. So, I paid $65,000, right? I paid $65,000. So my account went down $65,000. When will I get this money back? So I'll get $12,000 in the first year. Okay, equals $12,000 in the first year. Plus the second year, also $12,000. Okay, and the third year, same thing. Fourth year, fifth, until the fifth year. In the fifth year, I'll get $60,000. And so on. In the fifth year, I'll get $60,000 here. So I'll get my money back, $60,000 in 5 years. What I want to know is, will I get it back in 5 years and 1 day, or 5 years and 10 months, or 5 years and 364 days? How do I get this number? You'll see how much money I have left in the final year. And the money that I have left in the final year is how much? So I paid $65,000, and at the end of year 5, I have $60,000 back, right? At the end of year 5, I have $60,000. The remaining money is $5,000. I have $5,000 to get in this period. And And in order to know how soon I'll get it, I'll just divide 5,000, whatever I'm looking for, the remaining amount, over the cash flow that I'm getting in that period. Okay? Just to give you the intuition behind it, imagine what I paid wasn't $65,000. It's actually $60,000 and 1. Okay? How many periods am I going to get? It's much sooner. It's probably going to be 5 years and 2 days or something like that. Why is that? Because I got $60,000 in 5 years, and the remaining $1 I'll get from the 12,000. You get the solution behind it, right? Yeah, you're welcome. We're good? We're on track, guys. We're doing very, very good. So, same thing with the discounted. Instead of putting 12,000, I calculate the discounted value of each cash flow. And I'll do the same trick. How many years do I have? And it's usually between the 7th and 8th, I have to do the same calculation. So the final part is the crossover rate. I need your attention on this because Dyer said there hasn't been a year where he hasn't put a question on the crossover rate. If you get this today, if I'm able to explain it to you, you have one question for guaranteed in the exam. So, the crossover rate. You use this when you have two projects. Imagine you have two projects that give you these cash flows. Which one is better? Is this one better where you get the cash up front? Or is project X better where you get the cash more in the future? Okay? You can't really know. Okay? The only way I know the better project is the project with the highest NPV. And the one with the higher NPV changes depending on my required rate of return. You'll know what I mean if you just play with the WACC. You'll see that both projects will have different NPVs. So I'm going to give you 3 examples. Example 1. If my WACC is 9%, this is the NPV of both projects. This is the higher one. I would go with project X. If my WACC is 11%, it switches. I would go with project Y. Okay? Finally, if my WACC is 9.96%, I'll be indifferent. This is the crossover rate. Okay? How did I get 9.96%? Was it just luck, trial and error? No, although you can do a trial and error, but it's very efficient. There's a technique which is what we're going to do right now. In order to reach the weighted average cost of capital, in which you are indifferent between two projects. Any questions? So, let's go to question 13 in the chapter. You have project X and project Y. At what cost of capital rate would you be indifferent between the two projects? Immediately, you know, he's asking for the crossover rate. We plot in the two projects. The main trick is you calculate the difference in the cash flows between the two. Okay? And then you input these cash flows in the calculator and you calculate the IRR. That's your crossover rate. So let's do that together. If you want to write these down so that we can work on the calculator. So we're going to use the same thing as before. This is exactly the same. The only thing I changed was this guy. Okay? How to use a financial calculator. Let's clear the calculator with cash flows. Second, clear the work. Now we have a fresh calculator. Now we have to enter the cash flows. What is cash flow 0?
0.
Exactly. Cash flow 0 is 0, enter. Next, cash flow 1 is 990, right? enter. Next, cash flow 2, 210, enter. Cash flow 3, 375, get to that. And finally, cash flow 4. Okay, now we have a populated calculator. We're all good. So we want to exit the system. Second, quit. We're outside of the system, and now we want to calculate the IRR. Just click the IRR button and compute. What's your answer? 9.96%. Okay? So right now we have a question guaranteed is a good term. Any questions? Just talk it through again. You have two projects. You calculate the difference in cash flows. You plug it into your financial calculator and you calculate the IRR.
Quick question. You
Yep.
mentioned before with IRR that you can't use it for like non-normal projects.
Yeah.
Wouldn't this be a non-normal
Yes.
project?
This would be considered like an unknown project. Yeah. Will it be so this wasn't a problem because the negative came in the first period.
Oh, so it's even more.
But what you're saying is accurate. What if it came here, another negative here?
Yeah.
Okay. Let me look into that and get back to you. Right now, all of the questions I did for the crossover didn't have this problem. Okay. But for now, this is the way how you would calculate the crossover rate. But I'll double check on your question. We're good, guys? We're done for today. A bit early, but I want you to do the fill out the sheet for my evaluation, please. I just want somebody to throw it to in the mailbox. Okay? Anyone who wants to do that for me, I'd appreciate it. Before that, just the main issues. Evaluation project was superb compared to the whole classes. We did really well. There was a question in the exam where the answer was 0.288. Okay, and he gave you two answers. It's either 2.9% or 2.8%. Okay, it's fair if you got any of these answers right, and if you got that incorrectly, please email Dyer, and I'm going to speak to him on Monday to give you these points. Okay, because if you got any of these, that means you had a wrong issue. You knew the finance behind calculation. So anyone who got that question wrong, I think it's question 6 in form C. I don't know which question it was in the other forms. Email Professor Dyer, just so that it makes it easier for him to give you those points. He said crossover rates will always come in the exam, and office hours will resume today at 3:30. Again, thank you for listening.